Good morning. Welcome back. So, last class we did queue insertion, that is in queue operation, inserting the elements into a queue. We did the procedure, that is the trace of the algorithm itself, a program, and I also showed you the execution of it. Today we will be doing the deletion operation. Before that, I want to talk about the deletion. See, yesterday's class also I told you the elements of the queue are not shuffled or rearranged when you delete an element from a queue. That is, when an element is deleted. For example, I delete the element at the 0th location because the deletion happens from the front and insertion happens from the rear. Rear and front are the pointers which keeps track of the element inserted and element deleted. Getting it? It follows the first in, first out principle. What I mean to say is, for example, front is pointing to the 0th location. So once I delete that, the element in the location 1 will not get shifted to the 0th location. The 0th location remains blank only. That is, the elements of the queue are not shuffled or rearranged when an element is deleted. You cannot, it does not get rearranged. So only you increment the front pointer to point to the next location. So suppose you have filled in all the elements, that is, you have filled the queue to the maximum, that is rear is pointing to n minus 1 location. Then as you go on deleting the elements, still you cannot insert an element because the elements do not get reshuffled, and then the insertion should happen from the rear and deletion should happen from the front only, right? So since it do not reallocate or shuffle itself, you cannot, that is, the spaces deleted or vacated by the element cannot be reused by the new element. Suppose you have only one element in n minus 1 location also, it will show you queue full overflow only, because you cannot add until and unless you delete all the elements in the queue, reset the pointers of front and rear to -1, and then again start inserting the elements. So, for example, suppose you have or you're implementing a queue in an array based implementation of whatever data type of size n. In case of a linear queue, once you fill up the entire, I'm talking about a linear queue, once you fill up the entire space with your data, even though you delete some elements, you will not be able to add or put in some more data in the place vacated by those elements, because it should always be entered by the rare end, and the elements are not shuffled or rearranged, because there will be, once you finish filled it to the maximum, the rear would be pointing to the n minus 1 location, and till you delete the n minus 1th element, it will have data and it will always show me queue full. For that reason, what they did is they made circular queues. So, what are circular queues? Wherein the last node is connected to the first node. So, in case of circular queues, once your entire queue is filled, if you delete some data, you will be able to put in data, because the rare variable would start repeating itself. That is, n minus 1 is connected to the 0th location. So, you can, because the deletion happens from the front, so first element deleted would be the 0th location element, right? So rare would start repeating itself, like after n minus 1 it will go to the 0th location, because the last node is connected to the first node, so that you can go on inserting data into the queue as long as you delete data from it. So in circular queue, you can reuse the space vacated by the deleted elements, but in a single queue or a single linear queue, you cannot do that. Getting it? Hope you've understood the limitation of a single queue. And then when I say in general queues, yes, as long as you delete, you can insert n elements as long as you keep on deleting. But that happens in the case of a circular queue because the last node is connected to the first node. Yeah. So the elements of the queue are not shuffled or rearranged when the element is deleted. Let queue be a linear array consisting of n elements. Front is a pointer that contains the location of the element to be deleted, and rear contains the location of the inserted elements. Before the algorithm, I will show you the procedure, how exactly it works, and then we'll do the algorithm and the program. Please make a note of this. So, suppose this is the queue I have, wherein the number of elements in the queue is 5. So, it is not compulsory that I should have 5 elements in the queue only. Like, you can have any number of elements in the queue, but then if it's an array based implementation, you need to specify the size of the queue during compilation time only. So the size is fixed, you cannot increase or decrease it, but then it is not compulsory that you should have 5 only. For this example, I have taken it as 5. You can see that the locations of the elements are 0, 1, 2, 3, and 4, that is 0 to 4 is nothing but 5. So the value of n here is 5, and I have not deleted any elements, and q I have filled it because rear is pointing to the n minus 1 location and front is pointing to the 0 location, which means that I have still not deleted any elements in my queue. Getting it? Because front and rear pointers point to the front points to the element which has to go out of the queue, and rear points to the element which was last inserted in the queue. The rear points to the inserted element, both location of the inserted element, that is the last inserted element, whereas front is a pointer which points to the element which needs to go out of the queue. Getting it? Hopefully you've understood like what are front and rear, and it follows the first in first out principle. That is, the element inserted first would be the element to go out first. The insertion happens from rear and the deletion happens from the front. Now for the DQ operation, the steps what you need to follow for deletion, that is Q deletion or DQ operation, what should I be doing it? For Q deletion, what should I do to Q delete? Or DQ operation, the steps. First step is what you have to do, check for the underflow condition. So how do I, what is mean by underflow? That is, for example, if you are trying to delete from an empty queue, that is, there are no elements in my queue, then you are trying to delete an element from an empty queue. So that is the underflow condition. First you need to check for the underflow condition whether there are any elements in your queue or not for deletion. How do you do that? If front is -1, then it means that there are no elements in my queue. Yes, that gives to the underflow condition, that is whether there are any elements or not. If there are no elements, you need to give a message to the user underflow or queue empty, cannot delete. Otherwise, you should be able to delete. Whether you have one element also, you should be able to perform the queue delete operation. But if the queue is empty, that is there are no elements in the queue, then you will not be able to perform the queue delete operation. So the first thing when you are deleting, you need to check for the underflow condition. The second thing what you're going to do is you're going to delete front element. Delete front element. What do you mean by delete front element? That is, delete the element in the location to which front is pointing, correct? To which the element, delete the front element is nothing but delete the element in the location, that is, delete the element present in the location to which front is pointing to. Okay, pointing to is nothing but the index location. Getting it? If it's array based. Third one, after that, check whether the deleted element is the only element present in the queue. Only or the last element in the queue. Suppose I have queue of only one element, that is the last element I have deleted, and then my queue becomes empty. That is, I have a queue wherein it can, when front and rear are same, that is when front and rear point to the same location, it means that that is the only element in my queue. So you have to check whether the deleted element was the only element in my queue. If so, then you need to reposition the front and the rear pointers, or reset or reposition the front and the rear pointers to -1, because the queue becomes empty after deletion of that only element in the queue. So third one is check if the element was the only element, or the, that is the, or the last in the queue. If yes, reposition the front and rear to -1. Okay, if it is not, if no, then increment the front by 1. So what are the things? These are the steps which you need to follow for deletion. This is very simple and easy. That is, first thing when you are doing deletion, you have to check for the underflow condition. Underflow condition is nothing but queue empty, because if there are no elements in my queue, I cannot delete anything. So how will you know that? When you check whether front is equal to -1. If front is equal to -1, then it means that the queue is empty. Why do I check for front? Because front would be pointing to the element wherein the deletion happens from the front, and front is would be looking to the would be pointing to the element which needs to be deleted. If it has -1 or a null value, it means that there are no elements in the queue. So it means you are trying to delete from an empty queue. You have to give underflow or queue empty condition, and you have to give that error. The next one, if for example it is the queue has elements, it can have 1 to n elements. If the size of a number of elements in the queue is n, it can have from 1 to n elements, like one element can be there or n maximum of n elements can be there. So what you have to do, delete the element in the front. If there is no underflow condition, you delete the element from the front. Why? That is, deleting the element from the front is nothing but, suppose if front is pointing to the 0th location, then queue of front, that element, that is, you are going to delete the element which is present in the location front is pointing to, or the front location. You pass it as an index location, right? If it's an array based representation, then queue of front will give you the element. So you need to delete the element present there, and after deleting that, you need to check whether that was the only element in the queue. Suppose if that is the only element, after deletion of that element, the queue becomes empty because you deleted the only element or the last element in the queue. I'm not talking about last means n minus 1th element, because if my queue had only 2 elements, I would have not reached till n minus 1, and I delete both, still the queue becomes empty only. So what I mean to say is, if you have deleted the only element present in the queue and after that there are no elements in the queue, then you need to reposition or reset the values of the front and the rear pointers to -1. How will you find that that is the only element? When rear and front are same, if rear is equal to front, it means that it is the only element in the queue. If both point to the same location, it means that that was the only element in the queue. If rear is equal to front, then you need to reset the rear and the front pointers to -1, because the after deletion of that only element, the queue becomes empty. Suppose if it is not the only element, that is, you have still more elements in the queue, then you need to increment the front pointer by 1 so that it will point to the next element which has to go out of the queue. Here, while before only I have told you that the elements do not reshuffle or relocate their positions, that is, they will not change the position. You need to change the location of the front pointer. So now front pointer would point to the next element which has to go out of the queue. So this is the procedure for a DQ operation. Please have a look, go through this once, then I will take the example and I will start doing that. For your understanding, you can write it down also whenever you just go through this, because queue insertion, deletion, stack, push and pop are very important in data structures apart from arrays, which is a commonly and 100% asked question. Either they will ask you stacks or queues. Please go through this. Now I will start it. I will be calling the delete operation. How will I do that? Step 1. So, and before that, where n is the number of elements and item is a variable which stores the deleted element. So, I will say item is the variable which stores the element. So, for example, item. So, now let me start. called DQ function. I am calling the DQ function. Now what I will do? First thing is check for underflow. Check for underflow condition. What is underflow? If front is equal to -1. So what is the value of front here? Front is pointing to 0, right? So it is not -1. That is, I will say 0 and -1 not equal. So the queue is not empty. So the queue is not empty. Now, what is the next step I need to do? I need to delete the front element. That is, delete the element present in the front. How do I do that? What is the variable which is going to store? Item is the variable which stores the deleted element. Correct? ITEM is equal to Q of front. So, what is item? Is equal to, here Q of front is nothing but Q of 0. What is the value of front here? 0. So it is Q of 0, which is nothing but, it's not A of 0, sorry, it's Q of 0 because the Q is an array. Let us see here. What is Q of 0? Q of 0 is 88, correct? 88, so it gets deleted here because I'm deleting it. 88. Now after that you need to do what? After that delete the front element. Okay, I did that. Check if the element deleted was the only element or the last element in the queue. So what I should do here? I should check if it was the so how do you check? Check if is equal to, what is the value of rare? The value of rare here is, front is 0, rare is 4. That is 0 and 4. 0 and 4. Not, sorry, it is 4 and 0. Not equal. What you have to do? Increment the front pointer. Zero plus 1, which is equal to 1. So what is the value of front and rear here? Is equal to 1 is equal to 4 by the end of the first deletion. Hopefully you have understood. How will I do that? Now, where will front point to? Because I did front is equal to front plus 1, it will point here. Front will point here, rear will point front is pointing to the location 1 because I did front is equal to front plus 1 and rear is equal to same. Now, can I insert? Because I've deleted one element, by seeing the queue, I know that the queue is not full, right? So what is the insertion technique? First you need to check for the overflow. How do I check? If rear is equal to n minus 1. Yes, rear is equal to n minus 1 here. So it will not allow me to, it will show me queue overflow only. It will not allow me to insert an element because 78 does not get shifted to the queue of 0 location. 78 remains in queue of 1 location only. You are shifting the front pointer here because the next element which has to be deleted is 78 only, because it was the second to come inside the queue, because the first element got out. Now this is the element which would be deleted whenever I call the queue delete function, because the order is the same, first in first out. So whichever is come before 9, 78 had come, so 78 has to go first and then only 9 can go. That is the procedure. So this, suppose if I connect this to this location, what happens? I can do that because I can increment rear and it will point to the 0th location. Correct? That is a circular queue. So if there is place in a circular queue, if you delete, you can insert. Whereas in a normal linear single queue, you cannot do it. Hopefully you have understood what I mean to say here. The next is again call DQ function. If I call DQ function here, what is the first step? You need to check for the, you have to check for the this one Q empty operation, right? Check for underflow. So how do I check? Check if is equal to -1. So what is the value of front here? Front is 1 and -1. So not equal. The next is item is equal to Q of front. Okay. One minute, let me change the name. Let me use lowercase q only everywhere. So now q of item is equal to q of front. Which is nothing but q of 0. What was present in q of 0? Q of 0 is 78. So what will item have? Item will have 78. Now after that you need to check which was whether this was the only element in the queue you deleted. Check if what? Rare is equal to, because if it was the only element, then rare and front would be same. What is front? What is rare? Rare is 4 and front is 1, not equal. So equal. Then what you have to do? Increment front by 1. So is equal to, by the end of this, is equal to 2 and is equal to 4. Getting it? So by the end of this iteration, like front is 2 and rare is 4. So let us see how does the queue look here. Now see that I have taken out 2 elements because it has to be deleted in the front, and now the next element which has to go out of the queue is the element present at the location 2, that is 9. Fine, you can see that. So now if I try to insert an element, do you think it will allow me? By seeing this, definitely there are 2 places in the queue. The queue is not full. I can add 2 elements, but still rare. That is what I said, that when you delete an element, the elements of the queue do not shuffle or rearrange when the elements are deleted. It stays in that place only. That is 9 will not get shifted to queue of 1's place. It will be there in queue of 2's place only. That location only. The front pointer will change. Getting it? That is why until I delete all the elements and reposition the pointers to -1, I will not be able to insert an element in a linear queue. But if it's a circular queue, what happens? The queue of 4 would be connected to queue of 0. Then I can, that is, the rare pointer can repeat itself so that I can make use of that place for storing elements. So a circular queue can store n elements as long as you delete. But if it's a singly linear queue, you cannot delete. Once the queue is full, until the queue becomes empty, you cannot add new elements to the queue. So next, suppose if I call the dequeue operation again, okay? What happens? The first thing is check for the overflow condition, correct? And now what should I do? Check whether check for the underflow condition, because we are doing delete operation here. Check for the underflow condition, that is, check if front is equal to -1. What is the value of front here? The value of front is 2, right? So definitely 2 is not equal to -1. 2 and -1. They are not equal. Then what I have to do? I have to delete the element at the location front. How will you do that? Item is equal to Q of After that, you have to check that it is the last element in the queue. That is, was it the only element in the queue or not? How will you do that? Check rare is equal to front. If rare is equal to front, it means that that was the only element in the queue, and after deleting that, the queue became empty. Once it is empty, you need to reposition the front and the rare pointers. Getting it? Check rare is equal to front. What is the value of rare? Rare is 4 and front is 2. So, not equal, it means that it is not the only element which you deleted. Still, elements are there in the queue. The queue is not empty after deleting the element also. So, what I have to do? Front is equal to front plus 1, which is equal to 2 plus 1, which is 3. So, the value of front is equal to 3, comma, rare is equal to 4. Fine. What happens here? I'll go back. So, rare is pointing here. This one I deleted. So, I take this out and then I checked whether front is equal to rare or not. It is not equal. So, now front will be pointing here. And rare is pointing here, front is pointing here. Still 2 more elements are there in the queue. Whenever now if you try to do also, it will give you queue full because rare is n minus 1. Now we'll go back and I will want to do the operation. Which one? Now call the DQ function. So call the DQ function. Call first, what I should do? I should check for underflow. How will I check that? Check if is equal to minus 1. Yes. What is the value of front? 3 and minus 1. They are not equal. So, there is no underflow condition. If there is no underflow, then delete the element in the location front. So, item is equal to Q of front, which is nothing but Q of 3. So, item is equal to, what was there in the Q of 3? Item of Q of 3 location, 67 is there. So, after that, you have to check whether it is the only element which was deleted, whether there are some more elements in the queue or not, whether it was the only element which was deleted. How will you do that? Check if rare is equal to front. What is rare? What is rare? 4 and front is 3. Not equal. So what I have to do? Front is equal to front plus 1, which is nothing but 3 plus 1, which is 4. So by the end of this, front is equal to 4, rear is equal to 4. Yeah. Front and rear would point to the same location. Okay. Here front is pointing and then here rear is also pointing. So front and rear are pointing to only one location, that is, now you can see that 152 is the only element in the queue. So once when there is only one element in the queue, both front and rear point to the same one, because that was the last inserted and that would be the only element to be deleted, because there are no elements in the queue. So you can make out when there is only one element in the queue, then the front and the rear will have the same value, that is, they would be pointing to the same location. And once I delete that, it becomes empty queue. Then I need to reset the values of front and rear to -1. Getting it? So let me call the DQ function. So what will first check for? Underflow. How will you do that? If is equal to -1. What is front? 4 and -1. So item is equal to Q of, okay, I deleted the element there. Now you have to check whether it is the only element or not. Check if rear is equal to front. So 4 and 4. Correct? They are equal. What you have to do? Reposition the rear and front to -1 as the is empty after deleting the last or only element in the, okay. So how will I do that? We say rar is equal to -1, comma, is equal to -1. So what are the values of rar and front? -1 and -1. So let me check in the queue over here. I am deleting this. So rar and front pointers are no longer pointing here. What will happen to rar and front? Rar is equal to -1 and front is equal to -1. Fine. The queue became empty, right? Yeah. Now, again, if I call DQ, what happens? First thing is check for underflow. How will I check? Check if front is equal to -1. So, -1 and -1 equal. Okay. So, print Q empty underflow. So, this is what I am going to do, correct? So, this is how the thing works. Like first you have to check for the underflow condition. If it is not underflow, then delete the element at the front and then check whether the element is the only element in the queue or the last element or the only element in the queue which you deleted. That is, the queue becomes empty after that. How will you do that? If rar is equal to front, rar and front would point to that element only when that is the only element present in the queue. And then if it is true, then you need to reposition the rar and front to -1 because there are no elements in the queue after the deletion. Otherwise, increment the value of front. Because when you delete, the queue elements do not reshuffle or reposition themselves. They will be there in that places only. Getting it? Please have a look. After this, we will write the algorithm for this. Okay, I think we are short of time for doing the algorithm because it would take little more time. So we can do algorithm in next class, but then I will just revise today's class and then I will give you the homework questions. Q is a very important topic. So Q is a linear data structure where the insertion happens from the rear and the deletion happens from the front. And then for insertion, the things you need to check is whether there is place in the queue or not. That is for the overflow condition. And overflow condition, you check with the rar because insertion happens from rar, and if rar points to the n-1 location where the number of elements in the queue is n, then it means that there is no place in the queue. It's an overflow condition. Otherwise, first you need to check whether the element which you are inserting is the first element in the queue or not. Because if it is the first element, then you need to reset or reposition the front and the rear pointers. So how do you check that? If front is equal to -1, it is an empty queue. Then you will make front also point to 0 and rear also point to 0 and insert the element at Q of rare. So there will be only when there is only one element, then Q rare and front would be pointing to that element only. After that, what you have to do, if both the conditions are not true, that is, that is not overflow and that is not the first element, first you need to increment the value of rare, and then because it needs to point to a blank location, and then you insert the element at Q of rare. DQ is nothing but deleting an element from the queue. When you delete an element, the element do not change their location. That is, if I delete the element at Q of 0 position, the Q of 1 element do not get shifted to Q of 0. So, suppose you take a linear queue of n elements, then the queue is full. Even if I delete it, I will not be able to put in new element in that location in a linear queue. But if the queue is a circular queue, that is the last node is connected to the first node, then rare can repeat again. But again, the here also when you delete, the elements will not get shifted. But since rare it is in a circular form, rare can repeat itself, and then if the place is there, that is deletion, as long as deletion happens, you can insert a number of elements, that is you can insert elements as long as deletion happens in a circular queue. But in a linear queue it does not. Like even if you go on incrementing the front pointer, but then since the element do not get relocated or reshuffled, you cannot insert an element in the deleted place. In a linear single queue, in a circular queue, you can do that. For deletion, what I have to do, the procedure is, first I have to check for the underflow condition. What is the underflow condition? Like if you are trying to delete from an empty queue, it gives rise to an underflow condition. So when front is equal to -1, there are no elements in my queue, then it is an underflow condition. You need to tell that to the user queue underflow. Suppose if front is not -1 and I have elements in the queue, then you need to first delete the element present at the front location, and after that you have to check whether the element you deleted was the only element present in the queue, that is there are no other elements, that was the only element in the queue, or the last element you deleted from the queue. When I say last, it need not be in n-1 position, it's the last element which you have in the queue. After that there are no elements in the queue. So how do you check that? Rare and front would have the same value or would be pointing to the same location, or will have the same value when there is only one element in the queue. So check if rare is equal to front, then it is the only element, then you need to reset the pointers, again reset it or reposition it to -1 or null. Otherwise what you do is front is equal to front plus 1 or front plus plus. You increment the value of front so that it points to the next element which has to go out of the queue. Hopefully you have understood that. Please make a note of the homework question. Memory. So explain the memory representation of a queue using one-dimensional array and explain the need of a circular queue. Please make a note. Stay safe. To see you tomorrow. Take care. Bye-bye.